we are going to see the expansion method in the limit, and here we are going to see the fifth way to solve a limit is expansion method. And let's see the first example, like a part. Limit x tends to 0, e power x minus 1 divided by x. If we put x is equal to 0 in the term e power x, then e power 0 is equal to 1. 1 minus 1 is 0, and here what we have, 0 by 0 form again. Yes, but we are interested here like 0 by 0 form. And the 0 by 0 form, we know that this is what the indeterminate form, what we can call it as indeterminate form. Yes, and here what we can do, like this is indeterminate form and limit x tends to 0, and e power x minus 1 upon x. Let me show you what we are going to do here. We know that the expansion of the exponential terms like e power x is equal to 1 plus x plus x square divided by 2 factorial plus x cube divided by 3 factorial, and so on. Yes, we know that is expansion. So what we're gonna do, we just put the e power x expansion in the limit. Okay, x tends to 0, and at the place of e power x we are putting 1 plus x square upon 2 factorial plus x cube upon 3 factorial plus, and so on. And what we have remaining in numerator, there is a minus 1, and in denominator we have divided by x. So what we can see here, we can see like the term which is 1 plus and 1 minus in the numerator, which is going to be cancel out if we remove the round bracket. So this term is going to cancel, and here what we are interested to do, like we are interested to cancel out the x terms so that it would be easy to solve this limit, because if we put x is equal to 0 again in these terms, so this is again showing the 0 by 0 form, that is falls under the indeterminate form. But here what we're gonna do, we are interested to cancel out the x terms. So what we do, we can take x as a common in numerator, and here we have x in the denominator. So if we take common as x from the numerator, so x will be from here, x will be cancelled, this power 1, this is power 2, and yeah, what the final remaining term, limit x tends to 0, the remaining term I'm writing here like 1 plus x upon 2 factorial plus x square upon 3 factorial plus dot 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 dot. Yes, and what we can see here, if we put now if we put as x tends to 0 here, so this term is going to cancel out. First term is, there is no x term, so that will be remaining, this term is remaining. So we have 1, and this is going to be 0 x, because this is there is a x terms which is going to be, this term is going to be 0, and in denominator we have 2 factorial. We know that 2 factorial is equal to 2, but here not necessary get to know that like factorials, just this term is going to 0, and here again numerator is 0, so the whole term is going to 0, and so on. All the terms after, if we go from left to right, all the term is going to 0. The only one term which is remaining, that is 1. So this is going to be answer for this limit x tends to 0 e power x minus 1 upon x, which is equal to 1, because we have seen all the terms is going to cancel out. So this is the final answer for this limit.